Have you ever stopped to think what's actually going on inside your phone or your laptop, or what gives a massive supercomputer its incredible power? Well, today, we're going to pop open the processor's toolbox and take a look at the different digital brains that make our modern world tick. So let's dive right in. Okay, I know, it sounds like the setup to a really bad tech joke, doesn't it? But the answer is actually pretty simple. They both need a processor to do their job. The real difference, and this is key, is that they use vastly different kinds of processors. Because, as we're about to see, you need different tools for different jobs. So let's get down to it. At its heart, a processor's job is just to follow a list of instructions. But how it's built to follow those instructions, well, that's where you find two completely different design philosophies. Just imagine you're choosing between a complicated Swiss Army knife that does everything and a simple, perfectly made wrench that does one thing really, really well.
And this question right here is what started it all. It basically split the world of processor design into two camps. Should a single instruction be really complex and do a lot of work all at once? Or should every instruction be super simple and do just one tiny thing, but do it incredibly fast? This one choice changes everything. Speed, power, efficiency, the whole shebang.
So in one corner, we have CISC. That stands for Complex Instruction Set Computer. This is the Swiss Army knife approach. The whole idea here is to pack as much capability as possible into a single instruction so you can get jobs done with fewer lines of code. For a long time, this was the go-to design for desktops, and it's a philosophy that still powers a lot of high-performance computers.
And in the other corner, you've got RISC, or Reduced Instruction Set Computer. This is our specialized wrench. Instead of having one big, complex command, RISC processors use a very small, very simple set of instructions. And here's the magic trick. Each one of those simple instructions is designed to take exactly one tick of the processor's clock. That makes them ridiculously fast and incredibly power efficient.
You can really see the difference when you look at a basic task like multiplication. A CISC processor would just have one command, multiply, boom, done. But a RISC processor breaks it all down. It's more like, okay, first, let's load the first number. Got it? Now load the second number. Okay, now do the multiplication. And finally, store the answer. Yeah, it's more steps, but each tiny step happens at lightning speed.
Now, of course, neither approach is perfect. There are always trade-offs. With RISC, because the instructions are so simple, the software that translates our code, that's the compiler, has to do a lot more work. The final code also tends to take up more memory. CISC code is more compact, but its complexity can really jam up the works, making it harder to use clever performance tricks. One of those tricks is called pipelining. It's basically an assembly line for instructions, and since all the RISC instructions are simple and uniform, they just fly down that assembly line. That's a massive advantage.
All right, so we've covered the type of tool in the toolbox. Now let's talk about something else. How many workers you can get on the job at once? Because in today's world, doing just one thing at a time is just way too slow.
And this is exactly why we have multi-core CPUs. You can think of a core as a single independent worker on the processor chip. So having a multi-core processor is like having a whole team of workers all on the same project. Each core can handle a completely different task at the exact same time. This is what lets you listen to music while browsing the web and downloading a file, and it gives you a huge boost in performance.
You know, this highlights a really important difference in how computers multitask. A true multi-core system gives you multiple physical workers on that chip. Before this was common, a single-core processor would have to fake it, using techniques like threading to switch between tasks so quickly that it seemed like it was doing two things at once. It's really the difference between having two actual chefs in a kitchen versus one very hyper-caffeinated chef juggling two different recipes. Now, let's bring in our final tool. We've got our multi-tool and our specialized wrenches. We've got our small team of smart workers. But what happens when the job calls for an entire army of specialists, all doing the exact same simple thing over and over and over again?
Well, for that, you meet the GPU, the Graphics Processing Unit. A CPU, your main processor, might have a handful of really powerful smart cores. A GPU is a different beast entirely. It has hundreds, sometimes even thousands, of simpler processors all working in parallel. It's not the main boss running your operating system, it's a coprocessor, a special ops team brought in to help the CPU with specific, heavy-duty tasks.
And where does this army of specialists excel? Repetitive tasks. Think about what it takes to render a video game on your screen. That means calculating the color of millions of pixels over and over, 60 times a second. That's the perfect job for a GPU.
It's why they are the absolute heart of modern graphics, and it turns out, also the powerhouse behind the AI and machine learning revolution.
So, when we put all these pieces together, you can see that building a modern computer isn't about finding one single perfect processor. It's about assembling the right team. It's about filling a toolbox with just the right collection of tools for all the jobs it might have to face.
And that really is the ultimate takeaway here. There is no single best design. That simple, low-powered RISC processor in your smartwatch is perfect for what it does. Just like the complex, beastly CISC processor in a gaming desktop is built for its specific kind of heavy lifting. It always comes down to the trade-offs, and it's always about choosing the right tool for the job.
Which brings us to a final thought. The very device you're watching this on right now, it isn't just using one of these ideas. It's almost certainly using a combination of them. You probably have a multi-core CPU, likely based on that efficient RISC architecture, working side by side with a massively parallel GPU. So, the next time you use it, just think about that incredible team of digital workers, each with its own special tool, all firing away together, just for you.